Breakthrough in nuclear fusion energy announced. A major breakthrough has been announced by U.S. scientists in the race to recreate nuclear fusion. Physicists have pursued the technology for decades as it promises a potential source of near-limitless clean energy. On Tuesday, researchers confirmed they have overcome a major barrier, producing more energy from a fusion experiment than was put in. But experts say there is still some way to go before fusion powers homes. How does nuclear fusion work? The experiment took place at the National Ignition Facility at the Lawrence Livermore National Laboratory, LLNL, in California. LLNL Director Dr. Kim Butel said, "This is a historic achievement. Over the past 60 years, thousands of people have contributed to this endeavor, and it took real vision to get us here." Nuclear fusion is described as the holy grail of energy production. It is the process that powers the sun and other stars. It works by taking pairs of light atoms and forcing them together. This fusion releases a lot of energy. It is the opposite of nuclear fission, where heavy atoms are split apart. Fission is the technology currently used in nuclear power stations, but the process also produces a lot of waste that continues to give out radiation for a long time. It can be dangerous and must be stored safely. Nuclear fusion produces far more energy, and only small amounts of short-lived radioactive waste. And importantly, the process produces no greenhouse gas emissions and therefore does not contribute to climate change. But one of the challenges is that forcing and keeping the elements together in fusion requires very large amounts of temperature and pressure. Until now, no experiment has managed to produce more energy than the amount put in to make it work. How close is a fusion-powered future? The amount of energy they've generated in this experiment is tiny, just enough to boil a few kettles. But what it represents is huge. The promise of a fusion-powered future is one step closer. But there's still a long way to go before this becomes a reality. This experiment shows that the science works. Before scientists can even think about scaling it up, it needs to be repeated, perfected, and the amount of energy it generates will have to be significantly boosted. This experiment has cost billions of dollars. Fusion does not come cheap. But the promise of a source of clean energy will certainly be a big incentive for overcoming these challenges. Presentational gray line. The National Ignition Facility in California is a $3.5 billion, £2.85 billion experiment. It puts a tiny amount of hydrogen into a capsule the size of a peppercorn. Then a powerful 192-beam laser is used to heat and compress the hydrogen fuel. The laser is so strong it can heat the capsule to 100 million degrees Celsius, hotter than the center of the sun, and compress it to more than 100 billion times that of Earth's atmosphere. Under these forces, the capsule begins to implode on itself, forcing the hydrogen atoms to fuse and release energy. On announcing the breakthrough, Dr. Marvin Adams, Deputy Administrator for Defense Programs at the U.S. National Nuclear Security Administration, said that the laboratory's lasers had input 2.05 megajoules (mJ) of energy to the target, which had then produced 3.15 mJ of fusion energy output.
Don't forget to subscribe to my channel and turn on the notification bell for more up-to-date news.